right, parent absolute value function. That's going to be f of x or y equals the absolute value of x. F of x equals absolute value of x. Do y'all remember what absolute value means? What does it mean? The distance that it is from 0. The distance that it is from 0. And it's always going to be a positive number because it's a measure of distance. Parent, again, is just the most basic one. I believe you learned like the parent linear function and the parent quadratic function in Algebra 1. So we're going to do this by making a table. I'm just going to pick some x's to plug in. Usually when I have a choice of x's, I'll pick some negative numbers, 0, and some positive numbers. So I'm going to do -3, -2, -1, 0, and then some positives, 1, 2, 3. To find the corresponding y value, we're going to take the x's and plug it into the parent function. Basically end up having to do the absolute value of the x value. So for the first one, I would have absolute value of -3, which remember is just the distance that it is to 0. The distance -3 is to 0 is 3. For the second one, I would have absolute value of -2, which is 2. And then we'd have -1. Then we'd have 1, not -1. What's absolute value of 0? 0. Okay. What's absolute value of 1? 1, right. It always ends up being positive. Okay, and then I'm going to graph these so we can see what this graph looks like. So we have -3, +3, -2, +2, -1, 1, 0, 0, 1, 1, 2, 2, and 3, 3. So this doesn't make an X shape, this makes a V shape. This point right here at 0 is the lowest point that it's going to have. I'm going to use a ruler, but if you have your ID badge or a note card, you can use those to graph nice straight lines. Again, the lowest point that it's going to hit is 0, 0. Bless you. Because this one does not go down into the negatives because of that absolute value. Ta-da! There it is. Beautiful. So that lowest point on this one is what's called the vertex. I believe you've heard this word before when you were studying quadratics in Algebra 1. The vertex on this one is 0, 0. That's what's called its minimum point. Lowest point, aka minimum. It is, yes. If it was upside down, minimum. If it was upside down V shape, then the highest would be called a maximum. And it would still be a vertex. So this is the most basic one. Everything we do is going to be some sort of transformation of this. It might be wider, narrower, it might be flipped upside down, it might be shifted left or right, up or down, and that's going to be based on the numbers that we see in what's called the general form of an absolute value function. There's general form. We're going to pull more information in. The vertex in general form is going to be found by finding the point H, K. The only tricky part, you had this same situation when you learned about quadratics, the vertex on a quadratic. H is going to always have the opposite sign. So if you see a plus in here, you're going to write minus. If you see a minus in here, you're going to write plus. H will have the opposite sign.
Literally the same exact thing, except absolute value of vertex.
Okay. The A value actually can do lots of things. Based on the A number itself, it's going to be what's called either a vertical stretch, where the V shape gets narrower, or a vertical compression, where it gets wider. So that's the first possibility, vertical stretch or compression. And then it can also, based on its sign, the A value can also cause it to be a reflection over the x-axis. Reflection over x-axis. Okay, so to figure out which one of these it is, so first off, reflection over the x-axis is going to happen if it is negative. So I'm going to say if the A is negative. And then based on just the number part, that's how we can tell where if it's a stretch or a compression. When I say the number part, you're kind of thinking about like the absolute value of this number, so not the sign itself. So if the absolute value of A is greater than 1, it's going to be a vertical stretch. So that would be like a 2 or a 3 or a 4 or something like that. If the absolute value of A is between 0 and 1, then it's going to be a compression. What type of numbers are between 0 and 1? Decimals, fractions, yes. So if the number part is between 0 and 1, it's a compression. And then H and K, yes, they move the vertex, but they also can cause what are called translations, where you move left to right or up down. For the H value, H is what's going to cause it to move either left or right. And then the K value is what causes it to move up or down. And remember, when we write down the vertex, we write down the H with the opposite sign, so it kind of has an opposite effect on thinking about whether it's left or right as well. If you see a plus, so if this said plus H, that means it actually moves to the left. But if you see a minus number, that actually means it moves to the right. Up or down works exactly as you think it would. If you see plus a number, that means it moves up. If you see down a number, that means it moves right. And I'm writing all this because on each of these I'm going to have you describe how it's different from the parent function. All right, ready to try one? Seems like it would be hard, but it's not difficult. Okay, first thing I'm going to do is just find my vertex and then find how this is different than the parent function. So I can see I have my A right here, my H and K here, but when we write down the H for the vertex, remember we're writing that down with the opposite sign. So we're going to write down +1 for the H, and then the K is just always whatever you see, +3 for the K. And then I'm going to look at how this one's different than the parent function by looking at the A value and then also the HK causing a left, right, and up, down transformation. First off, the 1/2, it's not negative, so I know it's not going to be a reflection. But is it a number that's greater than 1, or is it between 0 and 1? Between. So that's what's called a vertical compression, which is going to cause it to flatten out. Vertical compression. Okay, and then I see a minus here. If we look back, the minus moves it left or right? Very good. That would move it right. So it's going to move right 1. And then I see a +3 over here. Is that going to move it up or down? Up. So it's right 1 and up 3. These are how it's different than right 1 and up 3. Not right 3, up 3. These are how it's different than the parent function. Okay, to graph. We're going to start by plotting the vertex. Step 1, plot vertex. Which is at +1, +3. +1, +3, there it is. Okay. Now the A value, we're going to use, it's kind of basically the slope of the right side of the V shape. So we're going to use A as the slope on the right side of the V shape. Okay. And what was our A value again? 1/2. So if we think about that as like a rise over run slope, what would a rise of 1 and a run of 2 mean? Which directions are we going to count? Like just like you're graphing straight lines. Up 1 and what do you mean by over? To the right 2. Up 1, right 2. So from that vertex, we're going to count up 1, right 2. Up 1, right 2. Okay. And then we're going to do the opposite for the other side. Okay. So we want that corresponding V shape that's over here. You can kind of think about it as they're basically just reflections across the axis of symmetry. But you can also think about it as this, just instead of going up 1, right 2, you would just need to go the opposite. Up 1, left 2. Up 1, left 2. So from that vertex, up 1, left 2. Up 1, left 2. And that basically gets the points on the other side of the V shape. So we'll do the opposite to graph points on the left. And then the most common mistake on these is people want to intersect them like an X. But remember, the 0.13 should be the lowest point on your graph. So you're going to do a little V shape, making 1,3 the lowest part. Ta-da, there it goes. And it should look more wide than the parent function because of that vertical compression. If you compress a V shape, it's going to squish out and get wider. All right, for the next one, let's look at it. I'm going to start by just labeling A, H, and K. Here's the A, here's my H, here's my K. Let's start by finding the vertex, the HK vertex. Which one do we write down the opposite sign for? The H. Very good. Okay, so what are we going to write down for our H? -1. And what am I going to write down for my K? -3. And then I'm going to talk about how this one is different than the parent function according to the directions. How is it different than the parent function? The -2 is going to do two things. One based on the fact that it's negative, and one based on the fact that it's a 2. So it does two things. What happens to it based on the fact that it's a negative?
It'll have a maximum.
It'll have a maximum. It's a reflection, so it'll be facing downwards, meaning it'll have a maximum. It's a reflection over the x-axis. Okay. Based on just the 2, though, the absolute value, so it would make it just a 2. What's going to happen to it based on just the 2? Vertical stretch, which causes it actually to get narrower. If you stretch out a V shape, it gets narrower. Vertical stretch. Okay, and then the H, based on the fact that it's a +1, does plus mean it moves left or right? Left 1, good. Left 1, and based on the -3, it's going to move down 3, very good. Down 3. Okay, using our steps that we wrote down on the left, first thing we're going to do is plot the vertex. That vertex is at -1, -3. -1, -3. Okay, and then we're going to use the A value as the slope of the right side of the V shape. Let's go look at what our A value is. Right now our A value is -2, which would be -2/1. So if you think about that normal Algebra 1 style rise over run, what is -2/1 going to be? Which way do we go for -2? Down 2. And which way do we go for a +1 run? Right 1. Very good. So from that starting point at -1, -3, we're going to go down 2, right 1. Down 2, right 1. Okay, and then I'm going to go back to my vertex to do the left side. I can't go up because I know my V shape is going to be upside down. What should I do instead to count the points on the left side? Can't go down to right 1. What can we do instead? Down to left 1. Down to left 1. Very good. And that'll get the other side. Down 2, left 1, down 2, left 1. And again, most common mistake I see when people graph these is they want to make an X shape. But remember that -1, -3, that's actually going to be the highest point on this one, the maximum. So when you connect, just make sure you don't go past there. There we go. It does look slightly narrower from the parent function because of that vertical stretch. It is definitely reflected, so it's upside down, and we can see that it has moved left and down. All right, we're going to go backwards on the back side. We have the graph already on the back. We want to write the equation for it. I'm going to just write that form over here so you don't have to keep flipping your paper over back and forth. F of x equals A times the absolute value of x minus h plus k, which remember HK is the vertex and then A is kind of like the slope on the right side of your graph. So I'm going to have us do an ink pair share on this first one here, meaning you're going to write the equation and then we'll pair up and share with a buddy. Ink pair share So what you're going to need to do is you're going to need to find the vertex, the HK, find the slope of the right side, and then put that together in your equation. A little ink pair share. I'll give you a minute. You're finding the HK vertex. You're counting the slope on the right side because that'll be your A value, and then you're going to put them together in your equation. Alright, let's go ahead and find a partner to share with. See if we all wrote the same thing. No parentheses, absolute value bars. No parentheses. Make sure you're using absolute value bars, not parentheses, not square brackets.
There's one thing you have to know, right? If you're gonna plug, wait, no, I put F section, I put G into F. It's negative 1.
Okay, like, if this was negative,
Absolute
would it
value.
become positive?
Alright, what was the vertex at?
I put in 5,
5, -2. And then what'd y'all get when you counted the slope on the right side?
-1.
-1. So we know that A is -1. So we're going to put those together in our equation. So we'll have y equals, -1. Negative or -1, doesn't matter which one you write. What am I going to write for my x minus h? X minus 5. And then what am I going to write for my plus k? -2. Here's the h, here's the k. The h will have the opposite sign. Very good. Alright, next one. We're going to have you talk together in your group. And I want us to do this one on a whiteboard. Final answer on a whiteboard. Same situation, you're going to look for the vertex, look for the A value. Final answer going on a whiteboard. Get your y equals, otherwise it's not a function. About 30 more seconds. Alright, boards up. Boards up. I see a lot of people forget their y equals. If you don't have a y equals, it's not even a function. Very good. 2/3 was the A value. Inside the bars should say x plus 4. Outside the bars should say plus 3. Perfect job, guys. Y equals 2/3 x plus 4 plus 3, because that vertex was at -4, +3. And then the slope of the right side was up to right 3. Alright, up next, we got a piecewise function. We did these on Friday. Do you remember? Piecewise functions? Okay. Remember a piecewise function, on the left side is the actual equation that you're graphing. So these are our actual equations. What is on the right side though? What are these inequalities? The domain of the equations, right? If you remember how I had you do this on Friday is I had you graph the whole thing with a pencil and then erase the part that's not in your domain. I'm going to do the same on this one. I'm going to have us start by just writing the actual equations. The first one would be y equals negative 3. And then y equals negative absolute value of x plus 5, which is what we learned how to graph today. And then y equals x minus 4. What type of line is that first one? Horizontal. Good memory from Friday. Again, most common mistake when graphing a horizontal line is people want to put them all right here. Does it go right here? No, where should I move it? Down to negative 3. Very good. Again, I'm going to do this in pencil and then I'll erase the part that I don't need. Right there or so. Now, if I were to read the domain out loud, that says x is less than negative 2. X is less than negative 2. I'm going to put my ruler right where negative 2 is. Here's negative 2, where x is negative 2. Which side of this is less than negative 2 then? The left. So which side do we erase? The right. Anything to the right of that negative 2. And then we'll adjust endpoint. It says x is less than negative 2, which means do I need an open or a closed dot? Open dot. Very good. Y'all are excellent remembering how to do that from Friday. Good job, guys. All right, second one. That's what we just did. So again, we're going to start by finding the vertex. If you don't see the h of the HK vertex, what is the h then? 0. So what is my vertex at? 0, 5. Okay, 0, 5 is basically just on the y-axis. 1, 2, 3, 4, 5. Okay. And then to find more points for my V shape, I'm going to use the A value as the slope of the right side of the V shape. And what is our A value? Negative 1, which is basically negative 1 over 1. So if we were to count this as a slope on the right side, we would count which way and which way for negative 1 over 1? Down 1 and right 1. So from that 0, 5 vertex, we're going to count down 1, right 1. If I needed points on the other side of the V, what am I going to count instead? Not up. We don't want to go up at all because that doesn't make a V. Down 1, left 1. Down 1, left 1. And then we'll look at the domain and adjust as needed. We talked about how to read this on Friday. A lot of people struggle with reading this, but what did I say it means? What does it mean when you have an X? Feel free to look at Friday's notes. I'll wait. What does that mean? First period figured it out in 1 second. Yes, Brandon. No, more specific. What does this mean? What does this mean for my domain? In between. Way to go. It means it's in between these two numbers. So we need to have a domain that is in between negative 2 and 3. I'm going to point to both of those. Here's negative 2. Here's 3. It needs to be in between this space. So we need to erase everything that's not in between. In between negative 2 and positive 3. And then we'll adjust our endpoints. On the side with the negative 2, what should we have? Closed dot. On the side with the 3, what should we have? Open dot. Looks good. Okay, last one's very straightforward. It's a linear function. Which part of that linear function are we going to graph first? The y-intercept at -4. Good. Okay, and then what's its slope? Its slope is 1, which is 1 over 1. So we'll count which way and which way. Upright, upright. Very good. Upright. Okay, and then adjusting domain in just a second. All right, there's the whole thing. Going back to look at the domain, that says x, and then what inequality symbol is this? X is greater than or equal to 3. I'm going to put my ruler right where 3 is. Here's 3. Which side of this is greater than or equal to? The right. So which side do we erase? The left. Anything to the left of that -3. And then adjusting endpoint. What kind of endpoint should it be for greater than or equal to? Closed dot. Alright, that looks beautiful. What a nice looking graph. Does this pass the vertical line test? Yeah, because even if you put a vertical line right here, it only hits one actual point. Good job. Alright, last one is tricky. If you worked ahead, you might have even gotten it wrong. Let's look at it. It's an AP question. You can tell by the font. Function f is a linear function, and it is graphed on the xy plane. They graphed it right here for you. If g of x is absolute value of x, which of the following graphs shows y equals g of f of x? Okay. So this one, it uses compositions. Okay, but we also probably need to figure out what this linear function is, because we are going to have to do g of f of x. For g of f of x, does this mean I plug g into f, or do I plug f into g? Plug f into g. Right, good. Plug f into g. But do we know what f is yet? No, we don't know f's equation. So the first thing you're going to probably want to do is find the equation for f, so that you can plug f into g, so that you can find the graph of the new function, whatever g of f of x is. I'm going to give you a couple of minutes. It's pretty challenging. Even if you figure out the equation, it's still pretty challenging to figure out what the graph is. All right, a couple of minutes. Talk with your group. You might want to talk about what y'all get for the graph of, or what y'all get for the equation of f, and then what'd you do? And then how are we going to figure out how to graph this new guy? Because this new one, I've never seen anything like this before. Again, start by finding equation f. Because you're going to plug f into g. And then you're going to have to figure out how the heck to graph that new function. It's a doozy.
I read that shit. This is super soft. Here's my no way. All these voltages. Wait. So all these that didn't even like dare to cross my mind. Wait, so he's older than you, but you're a year older than him. But y'all, no, you're like a year higher than him in high school, but y'all have the same class. So he has a higher French class, so you're chilling.
Yeah, I'm higher French class.
I'm sure that to be always younger than Ray, I'm sure you know the fact that he's older. It's too mind-boggling. Because Ali's actually just like a baby boy.
Sure.
No disrespect to Ali. You're not older than Ray.
Alright, I saw a handful of right answers walking around, guys. I appreciate all the table talk with your group. Let's start by first figuring out what was equation F, because we needed that first. What was f of x? Who thinks they got it? Ladies back here. 1/4 x minus 1. Very good. And then what'd you do after that? Plug f into g for the variable, which basically just means we're going to take f and write it right here. So that's our new function. 1/4 x minus 1 with absolute value bars. Now I haven't taught you how to graph anything like this, but it's still graphable. You would just have to graph it by making a table. Okay, so first off, I notice I plugged in -4 first because a couple of them had different values for -4. Let's see what that would be. 1/4 times -4 minus 1. What is that absolute value?
2.
Yes, that would be 2. 1/4 times -4 would be -1. If you subtract 1, that's -2. Absolute value of -2 is 2. And then we can cross off two answers. Which two answers don't have a point at -4, 2? Two answers that don't have a point at -4, 2.
C and B.
Yep, not C and not B, but the other two do have points at -4, 2. And then I looked at the last two and I said, well, they have different points at 4, so I'm going to plug in 4 also. Plug in 4. Absolute value of 1/4 times 4 minus 1. What's a fourth of 4? 1. And then if you subtract 1, you get 0. And then what's a fourth of 0? Or sorry, what's the absolute value of 0? 0. So we should have a point at 4, 0 also.
That knocks out D.
That knocks out D and leaves us with answer A, 4, 0. Tricky, right?